So
You should be good right now.
you can hear me?
Yes, you're
Yes,
good.
we can hear you.
Great. Okay, let's get started. And you can see my screen, correct? Very
Yes.
good. Okay. So hi, I'm Mike. I'm with Paragon Controls. The folks at Veritech set up this webinar, and what I've tried to do is take over the points that are mentioned on the flyer that was sent out, and what I'd like to do is add to that. So let's get started. Let's get started. Okay, so hi, I'm Mike. I'm from Paragon Controls. We do airflow and pressure measurement, and I have a slide presentation put together, PowerPoint, and I'd like to talk to you about airflow measurement and how we do things. Okay, so I think that part of the reason that Alan wanted to set this up is because in today's world, in the HVAC world, we have a very pressing topic that is prevalent in everything that we're reading about today, and it's indoor air quality. And what I'd like to do is discuss indoor air quality with you in the beginning, talk about some of the ways of handling it, and then I'd like to talk to you about specific Paragon products and the solutions that we can offer for these situations, as well as other industry trends that are going on. So IAQ is the hot topic. You know, this COVID thing has been affecting all of our lives for the last couple of years. Hopefully we're coming out of it. But, you know, what's most important is, the occupants' well-being and making sure that everyone stays healthy, and not only are they healthy, that they're productive. So these are important topics that go along with COVID and our health. But the other thing that goes along with it is because of a lot of the things that we're going to discuss, they're talking about more energy usage and the maintenance of our HVAC equipment. And I'd like to address all these items because these kinds of things have come to light much more in the last couple of years. And, we have to adapt so that we can make sure that we, stay ahead of things and keep everybody healthy. Risk management, this is something that I talked about for years in terms of, the owner's responsibility, as well as the engineer's responsibility to provide safe environments, and healthy environments. Just because, we say we do something doesn't mean we do it right a lot of the times. And it also doesn't mean that it gets installed correctly. So, if something is maybe designed correctly, but not installed correctly, there's a lot of people who could be liable or responsible for those kinds of situations. And part of the solutions I'd like to talk about is, mitigating some of those items. If you read the ASHRAE journal and a lot of the other documents, other publications that are out there, everything that they're talking about is, outside air, mitigating the COVID situation. And, all these entities, whether it's California, in California, we have Title 24 that says pretty much anything over 5 tons has to have outside airflow measurement. A lot of other states are going to be adopting that in the near future. LEED buildings all say it's mandatory to do outside airflow measurement. And for years, ASHRAE's had 62, and it's been updated to 62.1. ASHRAE also puts out in their publications right now stating that, outside air volume, because of the COVID situation, outside air volume should be increased. So what we're trying to do is a lot more dilution of particulates in the air, so that possibly, keeping down the COVID problems. But, because of that, we're going to tax our heating or cooling coils more. They'll use more energy and to maintain the thermal comfort that we want within the spaces. So, these are things that all the publications are talking about. They're talking about air changes per hour. They're talking about filtration rates increasing and the ability of doing filtration and UV lights to take care of killing off anything that might be in the air or entrapping it or diluting the air that goes with it. So these are all things that we're seeing in publications. There's probably people who are experts at this now in terms of how to balance out outside air, UV lights, filtration, but they're talking about, more outside air. MERV 13 is your minimum standard for filtration these days. And all these things are in conjunction with what we're doing in terms of outside airflow measurement. Another piece of the puzzle is keeping the humidity in the 40 to 60 range. We don't do anything with humidity. I know that Veritech handles dry steam in your territories, in your areas, and it being a dry space where you're in the desert, dry steam and other types of humidification equipment can play an important part in terms of keeping your environments healthy for your indoor spaces. So, I don't know if Veritech has another seminar to discuss dry steam, but if you're interested, I'm sure anybody at Veritech can help you out with doing humidification. Let's talk about some of the fundamentals of airflow measurement. And I want to start off with basically not just airflow measurement, but the business in general. So whatever we do these days, whether it's a new building or a retrofit or something like that, a lot of times, people look at it and say, well, we're just going to do this. But the decisions that we make on a project, are going to have impact to that building for a lot of years. So, doing an inexpensive fix or a Band-Aid situation or something like that, really doesn't work, because sure, we might be able to save a couple of dollars here or there or something. But if somebody's got to live with it for a lot of years, or there's a problem associated with it because it wasn't done properly, this has consequences for the building. The last couple of years, we've talked about, COVID's been in our face ongoing. Whether you believe in COVID or not, there is something out there that's an issue. Years ago, we had Legionnaire's disease. There's going to be additional issues in the HVAC world. And if we can build our systems such that when the next issue occurs, we're set up to handle it, that's a great thing. Maintenance on your building. Maintenance is not something to be assumed. I've been to many an air handler where the filters look like they haven't been changed in years. They're so loaded up, they're ripped through, and the air that's supposed to be filtered is not filtered. So, maintaining a building so that it works correctly as it was designed, these are important situations. Increased cost of operation. We're talking about bringing in more outside air. We're talking about more filtration. There's pressure drops associated with it. So we're talking about increasing the cost of operation of the building to make sure that it's safe and healthy for their people. These are things to take, take into consideration. And the other thing is, like I stated before, a lot of the stuff that we do and design doesn't always get installed the way we think it does. So putting in there a little bit extra engineering factor or design methods to ensure that it gets installed correctly. I know we have commissioning agents these days, and they're very important in terms of how things, work in the future. But, these are things that we have to consider from a real world situation. Next thing to talk about. Why should engineers care about airflow measurement? From a historical point of view, most of what we used to do was for, expensive processes. But in the last, I'm going to say about 10 years, things have shifted a lot in terms of what we're doing in terms of airflow measurement. And while we still do a lot of work for, expensive processes, the outside airflow measurement and fan array measurement and fan measurement has overtaken those other core businesses of ours. And so, everybody's looking to do that. Outside air, like I said, is mandatory for the lead projects, Title 24. These are all mandatory situations. And in a lot of other places, people want to have outside airflow measurement for hospitals or whatever. Another factor that's changed in the last bunch of years is fan arrays have become very common. I look at a fan array as a more of a premium product than just a standard product. And if they're going to be working with multiple fans, there's usually a building management system set up. And if there's a building management system set up, people want to see points on the system that they can monitor so that they're making sure they work correctly. So we work together with that very well. The other thing I'm going to talk about some, and I'm going to, the next couple of slides is, there's a lot of industry standards that are out there that were developed for airflow measurement. And the reason I talk about it is because these things are important in terms of how a product operates. We like to get involved with the product and make sure it's applied correctly and cost effectively. But the standards that were developed, while most of them pretty much are uniform, are pretty much ignored by the industry unless Paragon gets involved with it. I could ask a lot of engineers or owners and stuff like that about different things about airflow measurement, and it's really like a foreign language. But if I was to ask an engineer about how many CFM per ton or GPM per ton, they'd know it right away. So we like to educate people, and again, it's in consistent method with what the different say. And one of the things that we also talk about a lot is AMCA. I mean, AMCA does a lot of different testing. We do some testing at AMCA, and we hope to do more. AMCA right now is not letting people in to do testing because of COVID. And we're hoping as soon as that opens up, we're going to be testing more products because they regularly ask us to do that on the cycle. Okay, so industry standards for airflow measurement. There's basically two of them, but the one that we use primarily is something called equal areas. There's another one called log to Pepachev, and we do those on nuclear power plants because we have a lot of space in the ductwork and stuff like that. But in the real world, we don't have that much space for doing these long ducts. So in a more compressed duct situation, equal area traverses are what we use. Whenever you see an air balancer go out there and do a traverse, he'll have a little chart that looks like this little equal areas chart, and he'll fill in the blanks and he'll figure out what the numbers are for each particular point on there. And they prescribe up to 64 points in general on what the equal areas look like for any kind of duct, whether it's a square duct, rectangular duct, or circular duct. And the reason they want to measure a lot of points is because if you see this little diagram I have here on the left, there's a lot of dynamics and system effects that go on within a duct. It's not like this laminar flow or you have a straight wave that's moving across there. And this dynamic is going to change based upon the flow rates that are within the duct. So equal areas is our baseline for doing sensing points. The next thing that the industry has developed was minimum installation requirements. And I'll talk about it a little bit later on, but ASHRAE has a standard 111. And they've done so many tests on different ductwork layouts, and they've told us that these are the minimum standards for doing location of our sensors. So in conjunction with equal areas, having an installation requirement, we're going to be able to mitigate or try to keep the system effects at a minimum so that we can do the best job we can doing airflow measurement. You know, airflows within a duct, whether it's a round duct, I have a couple of pictures here, or a square duct, there's lots of little things that are going on. When you have an elbow or a transition, there's a lot of dynamics that are going on. And in some cases, you can even get reverse flow within a duct. So if the air is supposed to be moving from left to right, there's portions of the ductwork could be flowing back against it, against the normal flow. And so what we want to be able to do is stay beyond those areas where there's turbulence or eddy currents or something like that, so we can get the best picture of what's going on within a duct. You know, this slide, and I think the next slide, I've been using since I started with Paragon. Every spec that we have out there, they have some boilerplate in there, and they talk about ASHRAE this or NEB that, or you know, TAB this, and then if they have lead, they have all kinds of stuff about it in there. And all those things are great, because what they're doing is they're showing you what the standards are, and you know, we're complying with them, and you know, those are all good things because we're building our buildings to these standards. Well, there's all kinds of standards, like I said before, and you can find it in any of these publications about how to do airflow measurement. So I wish that more specifications would have airflow measurement in their boilerplate as to how it should be done. And in other parts of the specifications, they talk about all kinds of AMCA testing. And you know, in our world today, whether you're doing diffusers, dampers, louvers, fans, ERVs, silencers, all kinds of things, we would never do any, we just about never use anything that's not AMCA certified. So why shouldn't airflow measurement be the same way? They do certification, and there's a number of airflow manufacturers that participate with AMCA. So, you know, these are all good things, so that, you know, you're comparing apples to apples, or you know that you're getting the performance that you're anticipating. You know, I used to do a lot of slides where, you know, I took a lot of pieces out of the ASHRAE fundamentals, because 2007 was the last fundamentals, chapter 37. You know, they had all these diagrams of how things should work and what's the correct way of doing it and things like that. There's a standard 111 that AMCA even ASHRAE even talks more about how airflow measurement should be done. NEB, TAB, AABC, ANSI, they all talk about standard methods for airflow measurement. And again, I talked about AMCA. 611 is their certification program. 610 talks about their application manual. So this is not like mysterious stuff that nobody knows about. There are entities that know about it. We believe in conforming with them. And I talk about it a lot because there's a lot of other airflow manufacturers that don't necessarily adhere to all these things, all these entities that are out there. Okay, I'm off my high horse on that. Touching on some of the points that were asked, set up before we had this discussion. Let's cover some, a couple of baseline items. Here's one of them here. In a simple air handler, basically, we've been talking a lot about outside airflow measurement, and we do supply air measurement and return air measurement. And they, asked me to cover just the basics of, supply air, return air, and outside air. And basically, supply air is equal to return air plus outside air. So if we're bringing in more outside air, we'll be exhausting more, and there'll be less return air. On a cold day, maybe we'll just be bringing in a minimum amount of outside air, or a very hot day, maybe just a minimum amount of outside air. So we'll have more return air as part of the component. And these things balance themselves out with dampers, and they exhaust themselves out of the building. And another thing I talk about is a little note on the bottom here. Airflow measurements available through with your air handlers these days, and it's just a small cost comparison to the air handlers. And I'm talking about a decent sized air handler, not like a 5-ton, because 5-ton units are kind of like inexpensive, and that's about it. But if there's an issue in the field and people are trying to figure out what the issue is with air, if someone had put in airflow measurement in the air handler just to start with, when it was manufactured at the factory, that one little thing of checkbox or whatever you want to call it, it would pay for a guy to be out at the site for a day. That's how inexpensive airflow measurement can be. And it's a small item. The control guys want to see it, but also when you're commissioning a job, or if there's an issue at a building sometime in the future, just having a little bit of airflow measurement can make a big difference in terms of diagnosing a building in terms of how it's operating. I want to just take a step back. Paragon's been around for a lot of years, and we started off doing a lot of, expensive processes like hospitals. We did a lot of labs and research and clean manufacturing. We do a lot of work in the power generation. We do a lot of work with nuclear power plants in the United States and outside the United States. We're ISO 9001, and we're able to do that. Coal-fired plants. We're in the process of doing some big hydroelectric plants up in Canada right now. So these are like our traditional type products that we do and projects that we do. But the industry has changed a lot. Probably in the last 10 years, we've shifted more towards doing airflow measurement in air handlers than we do in those expensive processes, just because there's so many more jobs where there's an air handler and somebody wants to measure outside air, or the fan arrays have become so popular that when you have a fan array, you have a number of fans, you have a BMS system. It's a great tool to monitor, measure, and have a diagnostic tool for your air handlers. We still do a lot of the expensive processes, but that's probably more 20% of our business right now than these other air handlers, and whether they're a custom air handler or a packaged air handler. We have a couple of different families of products. and we'll talk about them as we go on. You know, we do probes and stations. We'll talk about that some more. We have a couple of different types of transducers, whether they're single point or multiple point. We do pressure measurements and controllers. And, you know, we serve various markets with these products, whether it's commercial, industrial, or research. So, you know, that's just a really quick overview of just the family of products. So what I would like to do now is also show you the various types of technologies that are available for doing airflow measurement. I'll talk about ours more at the end, a little more focused, but there's a couple others that are out there that, you know, that are marketed. They have, you know, good points and bad points, and we'll talk about that a little bit as well. You know, thermal dispersion has been around for quite a number of years. You know, it's a method of doing airflow measurement. There's a company called Ebtron. They do probably most of the airflow measurement with the thermal products that are out there. If you haven't seen it, this is what their product looks like. They usually have some kind of transducer box, and they ship their probes out. The air flows through the probe, and what they do is they're able to measure airflow. They have a heated sensor and an unheated sensor, and they try to maintain a temperature difference between them with the heated sensor. And if they can do that, maintain that temperature difference, they can calculate an airflow. And if you have an airflow that you can calculate, and you have an area, you can calculate a CFM. So that's how a thermal anemometer works, thermal dispersion. There's another technology out there called vortex shedders. Some end it with a K, some will end it with an X. Depends on how, you know, who you are, whatever. It's an interesting technology in that it works like when you see a flag flapping in the wind. When you see the flag flapping in the wind, it makes a beat. And what this does is it takes those beats and it counts them with the microphone, and the number of beats tells you what the velocity is over the vortex shedder. And once you know how many beats you've got, and you've got an area again, you can calculate a CFM. So it's a very interesting technology. There's also a couple of different manufacturers who are marketing single point airflow devices. These are differential pressure. So differential pressure is a way of measuring airflow. Again, if you know the area and you've got a static pressure reading before a mesh or a controlled surface, and you can measure a differential pressure after it. If you know this differential pressure and you have an area, you can calculate an airflow. These are primarily used for outside air. I call them checkbox outside airflow measurement. You know, a lot of people say good things about them. I'm a little more skeptical, and maybe I'm prejudiced, but I see issues with these in time, and we'll talk about that a little bit more. So those are your primary methods for airflow measurement that are commercially regularly available. Most of the other technologies, other than the pitot tube technology, you require a balancer. And what does the balancer do? The balancer goes out there and he takes a bunch of readings into a duct. He punches a couple of holes in the duct, and he takes some readings with it. And what he does is he takes his piece of paper with his graph for equal areas, and he takes a bunch of readings, and each one of those readings he writes down, and then he takes the average, and then he calculates an airflow, and then he multiplies it by an area. He's got a CFM. Well, like I said, the other technologies that are out there they depend upon the air balancer to set up their product from the factory. And the only CFM that the air balancer takes a reading at is at full flow. So if you have you have full flow, you take a reading, sure, that's repeatable. But what happens at part flow when there's dynamics that are going on within a duct? So, while the air balancer does a very good job in terms of measuring that full flow, part flow is a real issue. And so what we believe in is, taking that measurement as he does with equal areas, but applying it to a probe or a sensing network that can take into account equal areas all the time and take a snapshot of it on a regular basis. So Paragon, and there's another company, Air Monitor, that makes something called a insertion probe that's called an averaging pitot tube. The one on the right is our standard. It's an anodized aluminum, built to last a long time. It's built based upon a phenomenon that a German engineer, his name was Feckheimer, found out about in the early 1900s, where they find a total pressure or velocity pressure goes into the leading edge of a tube. But if you go 20 degrees off on either side, you'll find that you're back at just the standard static pressure. So our averaging pitot tube is basically a tube within a tube, and we set them up with the right number of sensing points based upon the size of the duct. So we make those averaging pitot tubes, but we take it a step further. And what we do is we build stations. And the reason we like stations so much is because, it's really it's really a lower overall cost because we build them at the factory. Factory labor is always cheaper than field labor. We build these things all day, every day. So we're very efficient at doing it, like than the guys doing it in the field. In the field, since guys don't do this all the time, they really don't know necessarily what they're doing. So a lot of times you'll go to the field and you'll say, like, what was this guy thinking when he put these in? Because he's done some screwy things, whether it's putting in the tubes or taking care of the tubing that goes back to the transducer. So this leaves a lot of installation issues. It doesn't leave it to chance. If a installer can read, the arrow that shows the direction of airflow, if you can screw it into place correctly and connect up a couple of tubes, you pretty much have a perfect installation every time. And so we build these stations, and we build them all different shapes and sizes. I'll show you some pictures of them later on. But I think this is something that really sets us apart from our competitors in the airflow industry, is that, we're selling you a finished product with a matched transducer. We'll talk about that a little bit more. So it's really plug and play and ready to go. It's not like leaving things up to chance. Okay, I'm going to talk to you just a little bit more about the various technologies that are out there. I always thought this was an interesting graph that's out there. And it shows the relationship of how the different technologies work. The red line shows a thermal dispersion device, which works on a square root curve. And you can see that at the low velocities, they have a high gain, and then it flattens out as the velocities increase. The black line on the bottom is where it says DP. Those are how our pitot tubes work. And we're measuring a differential pressure over an area. So we're doing a lot of different sensing points. And it's a kind of flat curve at the lower velocities and then it picks up as the velocities pick up. And then the vortex shedders, which we showed you before, which is the ones with the microphones, they're a linear device. So just different math that goes into them. The different technology offer the math that's associated with calculating those airflows in to give you a proper CFM. Interesting method of how the math works out on the different technologies. I thought this would also be interesting. Alan had talked to me about, is airflow measurement set and forget? In general, I'm going to say the answer is no, especially for duct or outside airflow measurement. And most of the reason that they're not set and forget is because, different technologies require different amounts of maintenance. We find that the thermal dispersion probably requires the most maintenance. They have, if you remember when I showed you the little sensors that they have for measuring temperature, and they have two sensors and they have to keep a differential temperature so that they can measure the airflow. They seem to get gummed up pretty easily, and you can clean them with like a Q-tip and alcohol, but it's kind of tedious. The other thing that's an issue with both the thermal dispersion and the vortex shedders is, since they're the size of the sensing element and how they have to have air flowing through it, and it has to have straight air flowing through it, they have low sensor density. So they cannot comply with either equal areas or log to temperature. So that's an issue, because if you don't have the sensor density that either the balancer uses or any of the other fundamental agencies talk about, you're going to be losing out on information within that duct, and there's a lot of dynamics in a VAV system. And like I said, in a constant volume system, maybe not as much of an issue, but in a VAV system, it's definitely an issue. I have a little bit of a joke there in terms of accuracy for the thermal dispersion, because them, like the vortex shedders and the differential pressure, these are all set up at full capacity, full CFM. Nobody ever goes back and says, okay, what's the velocity at 75% of my reading, 50%, 25%. And if you're going to miss out on that information, which is where most of these systems live on VAV, we're at 70, 30% volume a lot of the time. You don't know if you're getting a correct reading or not. A lot about, people say, yeah, these devices are very accurate because, the balancer said it's this and it's reading that, and, we have no issue with it. But, you're going to find out that at part capacity, you're going to find large deviations if it's not all set up correctly by an air balancer at those different velocities, because of the information they're missing out on at lower velocities. Another item that we were talking about, Alan and I, does temperature, humidity, and altitude play a factor to the various technologies? And the answer is definitely yes. We publish this box with all of our submittals that we do, and it talks about velocity, versus area, and flow rates and things like that. That's for our technology. I don't know if the other guys publish formulas for how theirs work on a regular basis. We found that altitude and temperature is much more plays much more of a role than humidity. So every selection that you'll see from us will take into consideration the altitude at which the product is working at, as well as the temperature will either be plugged in on our outside airflow measurement products. We always supply a temperature sensor so that the transducer can update its air density calculations based upon the outside temperature. So temperature is extremely important for all of our products. It's especially also important for the thermal dispersion. So what we were talking about earlier was the two sensors being close to each other, and they need to see the same temperature air going past them at all times, because what they're doing is they're trying to maintain an offset. So if there's some stratification in the air that's going past their thermal dispersion device, it won't read correctly. Minor item, I don't know if that's big, but just we're touching on temperature and humidity and altitude affecting the sensors that are up there. Humidity we also find is always a factor, especially for outside air. If you've got humidity issues and moisture is depositing on the sensor, the thermal and the vortex DP, they'll manage to pick up more particulates, and if that becomes an issue, you're not going to get a reading, so it kind of gums up the works. So that's kind of a review of what we have in terms of the various technologies and how they compare. I'd like to talk about some solutions for outside air and duct measurements, fan arrays, and complete air handling solutions. A couple of years ago, I came up with this slide, and I like to say that Paragon tries to do a better job because we're better by design. I'm going to show you some accuracy tables from AMCA, third-party testing, where we can show that we're 0.35% accurate over a wide range of flow rates, 0.35% or better. The product that we provide is a very flexible product, and I'll show you some pictures of stations and stuff like that. We can provide probes, but we like to provide stations. This way, if you put in a station, you're going to get it correctly installed. It's more cost effective to do a station than a probe, and it just makes for a better installation. In terms of longevity, you're going to find that our product keeps working, and that's the reason why our type of product, whether it's us or Air Monitor, that's what they use in all the industrial products, all the industrial projects. Whether it's a nuclear power plant or a coal-fired plant or something else, they all want to use an averaging pitot tube because they just keep working. Even if you do have issues with something loading up on a probe or something like that, or not enough maintenance or something, you'll find that our products keep working, and it's because of the inherent design that's built into it, so it has some kind of redundancy built into it. Last thing that I'm going to say is return on investment. Since it's a product that keeps working, it's built to your specific application, you get the accuracy, it gives you a really good return on investment. And I'm going to show you some more about savings associated with operation of the building. Okay, spinning back to our problem that we've been talking about right from the start is indoor air quality. And, let's talk about some mitigating solutions. And one of the biggest ways of handling indoor air quality is bringing in more outside air. So for a long time, well before COVID or anything like that, they always used to say dilution is the solution. So anybody who's worked with a lab, there's these fans that you put on the roof, and they designed to put up a high plume so that the air shoots up into the air, gets mixed with a whole bunch of kinds of air that's out there already, so that if there's anything nasty in that air, it's like dissipates into the air. So we're diluting it. So what we're talking about these days with COVID is, dilution is the solution. Bring in more outside air, so that the probability of having anything nasty in the air is taken away. And the other thing that we're talking about a lot these days is filtration. And, MERV 13 is a minimum, but that, if you're going to upgrade your filtration, you're talking about more expensive filters and possibly more brake horsepower for your fans, because those filters that can trap more also have higher pressure drop associated with them. Outside airflow measurement. So Paragon provides many solutions for outside airflow measurement, whether it's a retrofit or a new air handler. We have all kinds of methods for doing it. And I'll share some pictures with it. One of the things that, very, very stringent regulations in terms of certification and doing things properly. This is us testing our product at AMCA, and they certified the data. It shows for an outside air measurement. We have a couple of different OAFE series products right now. This is the OAFE 2000, OAFE 1550, excuse me. OAFE 2000 will be tested as soon as we can at AMCA, and we're looking to get the same kind of results as this. But as you can see on the far right hand side, we're staying within 0.3% accuracy from 99 feet per minute to 1200 feet per minute. And that's a range where most of our airflow measurement is done in general. I mean, in a supply duct, we might see 1500 feet per minute, but that's usually not an issue if we bump it up a little bit of CFM. So across the board, the transducers show great accuracy. And this is done by third party. It's not us saying whatever it is, we want to say. It's somebody else who's certifying our data. And you can look it up on their website. We offer many solutions in our catalogs. We show a number of different diagrams on how we can do things. Here's some real world examples. This happens to be a retrofit where somebody had a unit and they wanted to add outside airflow measurement. So we told them, take the hood off, give us the dimensions for the flanges. We'll make the airflow station the same size as your damper, but the flanges will be the same size as your hood flanges. And so they did that. They took off the hood. We built the airflow station. They were able to bolt the hood back on and airflow measurement. The casings are 16 gauge galvanized, so that's a robust piece of metal. And if you want to paint it, you can paint it, but it's going to last a long time and give you an accurate airflow measurement system. Here's another system where it's being installed. This happens to show a bell mouth, fit right into where the outside airflow measurement is. They're in the process of putting it together. That little tube hanging down will go to the transducer. Then they'll put a bird screen over it, so it's good to go that way. That's like I said, a bell mouth. Here's a job that I took a picture of at this is at Sandia Labs, Albuquerque. It happens to be a very large indoor air handler. Just to the left of it was a supply air shaft. And you can even see that there's a little, dust on it. It's been in operation for a lot of years. I went over and took a look at it, and there's parts of it that are galvanized. There's parts of it that are aluminum, the anodized aluminum. There's parts of it that are stainless. And I found that the stainless and the anodized aluminum stayed the cleanest. The galvanized showed the most dirt of it on it. So it's a system that can work for a lot of years. Low maintenance, works very nicely. Bell mouth again. Also, you'll notice this is kind of a standard for us. You'll see that the dampers are running horizontally, and what we'll do is we'll do just about every system for outside air with the probes running vertically. We found that that's the best way of getting an average. If you run the probes horizontally, there's going to be stratification occurring because of the damper blades. And this way we get a better average by doing it vertically. Another thing that people are interested in doing these days is doing a min OA and a mod OA. This is a retrofit of a min OA where they took a section of a damper that should stay open pretty much all the time, but they need to prove that they're bringing in outside air at any time, minimum outside of air. So here's one that we was mounted onto it. Again, nice bell mouth. And it's just measuring the min OA so they can prove that they're bringing in the required amount of air as a min OA at all times. And the other dampers are mod OA and they operate as they need to. Here's another item that we do. We talked about the airflow measurement, and we talked about it for outside air being from 100 to 1200 feet per minute on our testing. Well, what we found is that while we can measure accurately at 100 feet per minute, 99 feet per minute, the best thing to do is actually bump it up a little bit to about 200 feet per minute as a minimum. And the reason is because of environmental conditions. I know that the guys up in Albuquerque was doing a school, and there was a number of units, but one of the units happened to have a airflow the entrance to the outside air would happen to be in the direction of airflow from the wind on a regular basis, and they were getting some issues. Well, the reason we were able to solve that problem fairly easy at the minimum airflows is because what we do is we make sure that we keep the velocities up a little bit, and we can also tune the transducers. So whether it's a new unit or an outside or a retrofit, we can take those areas, even if they're oversized, and reduce them with a bell mouth design like this that pretty much drop right into place for a unit, and we can give you better accuracy by keeping the velocities up. And these products have like basically a thousandth of an inch pressure drop, so it's not going to be an issue for your existing system. Another example of a retrofit. This was a large damper at a very low velocity was designed. And basically what was happening is once they cracked the damper, all the air would be going in there from the outside air, and it was way too big, not controllable, poor situation for measurement. So we proposed and installed this one where most of the outside air damper was actually blocked off, and we reduced the area so that it become manageable for the damper, as well as a better measurement situation for the outside air. So it's not just what the unit is, it's what we can bring to the job also. Many of the units that we do on packaged units. This one happens to be a system where many of the packaged units have one size opening, and it could be a wide range of tonnages. Well, a 100-ton unit, which I know this is a bit larger unit, doesn't have the same outside air requirement as a 75-ton unit. So again, what we've done here is we've cut down on the area for that 75-ton unit so we can make it manageable. This unit in particular also happened to have a bulkhead that ran between them, and the dampers were mounted on them. So we made the airflow station to match up so that it just drops right into place. So, these are things that we do to make outside airflow measurement accurate, and it's not just a kit, it's something that you get from us. Accuracy is in the details. The devil's in the details. I showed you a graph or a chart with showing 0.35% accuracy. That's great. In the lab, it shows that the product works. It's a matched situation. It's a good product in terms of how it's designed. But the devil's in the details. If we want to get accuracy, we need to have componentry that works correctly. So, when you order something or you design something with Paragon, the heads that we put in there for sensing are put in there for a specific application. We calibrated over 12 points. We used very accurate heads to start with. We always put a feature in there called an auto zero. This is something for ductwork and outside airflow measurement. An auto zero valve is a very interesting device. It's sort of like a self-calibrator, and that what we do is for just a couple of seconds every hour, what will happen is the transducer will hold its setting for a couple of seconds. And what we'll do is we'll physically cross the lines with the auto zero valve, which what that does is it zeroes out the reading for a couple of seconds. It takes into account any deformation in the DP head that might occur over time, and then we open it back up. That way we can maintain that we keep a zero calculation correct into our operation of our system. So it's an interesting device. Like we do this on all the outside air and a lot of the low flow ductwork applications. In our processors, we use 24-bit processors on a lot of what we do. So what we're doing is we're measuring 16 million points over the prescribed range of what that transducer does. So that gives us really good accuracy, lots of steps that we can see and analyze to make the product work correctly. The square root functions built in. I showed you those graphs before of the different technologies and how they work. We have the square root function built in. We also provide, let's say, this kind of system anomaly that's happening. We'll also provide you with some extra points in the field that say it's the balancer might find that there's some kind of anomaly that's not anomaly that's not working perfectly linear like it should be. Well, we can augment our linear output with these points to give better representation in the field. I was saying everything is factory tested. All our stuff is NIST, so it's sent out to be calibrated on a regular basis. And these are not things that you're going to get from a controls guy where he says, "Oh, I can do that." Sure, they can provide some components, but you're not going to get all these features. We're also going to provide you with the building management interface that you're looking for, whether it's BACnet, Modbus. We still have some onward products or an analog if you need to be incorporated. These are other details, like I said, the custom sheet metal shop installation. These are all savings that the owner is going to recognize in the long run. And in terms of owner recognizing savings in the long run, this is a chart that shows based on a 4,000 CFM unit, because AHRI says that's the average size unit that's sold. Albuquerque weather taking into consideration. If you use your economizer, if you use it and it's an accurate situation like we can provide, where I rounded it up to 0.5% error, over 10 years, you're only going to waste about $770, $780 of energy by keeping your outside air measurement accurate. But if you have other systems where you're going to have more inaccuracy, where it could be 10 or 15% off, there are big costs to the owner in terms of energy, because you're going to have to do more heating or cooling, and that's, $15,000 would pay for another 4,000 CFM unit in 10 years. So these are significant savings to be recognized. I know that DCV is still a method for bringing in outside air, and our devices can work in the DCV situation. So, that's something that's, available through us as well. Changing gears a little bit in terms of set it and forget it, in terms of airflow measurement. There is one area that we find that is pretty much set it and forget it, and that's measurement at the fans and fan arrays. And I'm going to talk about that for the next bunch of slides. Paragon has been making devices for measuring at the fans for a number of years. The picture on the right is what we call an FE 1050, and we've been making those for a lot of years. It was the industry standard until the PZO rings or the PZO taps came along. And we think that the PZO rings and the PZO taps are great. They do a nice job of measuring. There's nothing in the inlet bell of the fan anymore other than these two ports. And it's a really nice method for measuring airflow at the fans. And, everybody wants to know what's going on with their fans these days. So, I know that Veritech supplies a lot of product with the fan arrays, direct drive, fan arrays, high reliability, quiet, energy efficient, good method for doing fan arrays. Paragon has a product that we specifically use for airflow measurement, the fan arrays. I got a text from Alan that my time is over. You've heard most of what I had to say. Anyone would like to continue on, I'll continue on. I'll run through the last couple of slides. We sell a very nice product for fan arrays called a FATS 1000. It's got a nice architecture to it. What happens is you have the main head unit, and then you have transducer modules at the fan. You can even include outside air, and it all networks together. Something newer for us is a multi-trans, measures up to 3 systems, do outside air, all kinds of things with it. We call it the multi-trans, but one of the things I've been talking about is we can call it an IAQ trans. Since that's such a popular thing right now, we can do outside airflow measurement and filter loading with it, and it's all incorporated into the device. We can do fan arrays with it, or we can call it an AHU trans, so that it's taking care of outside air, filter measurement, fan or fan arrays, discharge air pressures, all kinds of different features that are available with it. I'm going to race through this a little bit more. A lot of flexibility, does a lot of different things. This display is programmable to your specific applications. So measuring outside air, supply fan arrays, return fan arrays, filter DPs, discharge air pressure, differential pressure across a coil, any kind of measurements you want to do. So, that's very important. We talked about, filtration and indoor air quality. And we do a lot with that these days because of the multi-trans. What's neat about it is that somebody doesn't physically have to go up there and check them anymore, or you don't have to assume a certain interval for changing them. You can actually get a reading from a device and say, okay, it's double what it's supposed, our usual filter pressure drop is. It's time to change the filters out. So it's a good way of monitoring your upgraded filtration that you're providing. Again, racing through some of these things, we just don't take shortcuts. We give a lot of sensing points. We can provide very accurate information in terms of how things work. In terms of doing fan arrays the way we do it, Pat Fay has pointed out to me a number of times that not only does it, capture the mechanical, but it also captures the electrical information on a fan array. So no current sensors are needed. And it's a single technology that works very nicely for fan arrays. One quick point, we do pressure monitoring. It's an older device. It's all stainless steel, but we can monitor or control 1 or 2 spaces. It's a product that the CDC uses across the country. I've talked about a lot of our advantages that that we can offer. Something I always talk about is that pitot tube technology is the most accurate and reliable method for airflow measurement. And every time an airplane takes off, it uses pitot tube technology, whether it's a Cub or a Grumman Tiger or a Robinson R-44 or the most sophisticated aircraft that's flown today. All of them use pitot tube technology to measure airflow, and that's what we do. We offer solutions for outside air, confirming air changes, optimizing maintenance. We also offer smart solutions in terms of, we want to ensure that it's properly installed, simplify things, single source responsibility. It lowers the cost because you can have all those features built in at an air handler manufacturer, and you can monitor it versus via BACnet, Modbus, or analog. And I always like to finish off with something, but wait, there's more. I love that. This happens to be a stainless steel probe that we got back from a carbon fiber recycling plant. Tested it versus a perfectly clean one. This one's absolutely furry with particulates of carbon fiber, but it tested out to be within 3% accuracy of a clean one. And that's what I'm talking about in terms of inherent redundancy. I mean, we believe in maintaining equipment, but even if the equipment is not maintained and some of our sensing points are clogged, we're still going to give you a pretty good reading as to what's going on within a duct or an outside air. So, this is what I have for my final slide. I want to say thank you for participating. You can email me directly. It was at the beginning, or the best thing probably to do is, email somebody at Veritech if you have a question or an application. We're always happy to help. We're always happy to help in the design process. And that's what I have to offer. I hope you all stay well. I guess if anyone has any questions, I'm more than happy. I don't know if I have to wrap this up or not. Anyone have any questions I can help with? Okay, if no questions, I'm going to sign off, and everybody have a good day. Take care.